Hello, everybody. I was going through some of my classes today and realizing that, I was way far ahead in one and not so far ahead in the other. So I was spent most of my day trying to catch up other classes and stuff like that. And I got, I'm current in all my classes, so I figured now would be a good time to go ahead and try to finish knocking out some of my Cisco stuff. And I have all but I think 4 or 5 labs done, and I'll be done with the semester. The reason why I'm so far ahead is because I do this stuff every day, so it comes almost like second nature to me when it comes to implementing things. But what I wanted to show you guys, there's some concepts that are going to be kind of hard to get out of the gate, which took me a little while to get. Not saying that that I'm faster than everybody, but the information you may never have heard of, you don't understand exactly what the different concepts mean, or how they're implied, or whatever the case may be. So what I'm going to do is I'm going to go over some of the terms that are used, where they sit, how they sit, and how they're used in different applications. So, and what I mean by application, it doesn't mean how it works, or not the how you interact with it, but where you would apply it in order for it to work. So, the big thing that you're going to run into in the CCNA is DHCP and NAT. DHCP, as most of you should know, is automatic configuration of IP addresses in your network. So you don't have to go to, say 300 or 400 devices and statically assign them IP addresses. You have a DHCP server, whether it runs on a Linux or a Windows server, and you replicate, the request comes in for a DHCP, it sends out the request, or the offer, the um, device or sends a request and says, yes, I want that IP address, and then the server sends back the acknowledgement. So that's the DORA, Discover, Offer, Request, Acknowledgement, on how that works. So it'll send, once the request and all that stuff comes in, the acknowledgement happens, and then that IP address is taken out of a pool and placed on that interface. So in that regard, that is the very first thing that we're gonna see. And then you see NAT. NAT is network address translation. NAT allows you to take one IP address and translate it to another one. So in this case, you have the 200, 209.165, 200, 254 subnet, and you end up being able to NAT that to a 192.168.2.20.254, or the 10.0 or the 11.0 network, depending on how you have your pools set up and stuff like that, will determine how it works. But the idea when you're dealing with NAT and stuff like that, the first one you'll see is NAT overload. Or I'm sorry, DHCP and NAT IP services. That allows you to kind of automate your network. In a matter of speaking, the DHCP allows you to automatically assign IP addresses to your end users, your laptops, your PDAs, your computers, your printers, your servers. Well, typically you wouldn't DHCP assign a server. You would statically assign those, but and all your end users. So that's what you would do with DHCP. Now NAT allows those users to be translated from the private IP address range that you're using to a public IP address, or a private to a private. It can be done that way too. So like in the case where I work, we NAT from the customer side to our managed information service, or our MIS that we provide them, because our network is really secure. We have a lot of intrusion detection, firewalls, antivirus, you name it, we're watching for it. So by doing that, we allow a client to NAT a router that we manage, and say, okay, we're going to NAT from your 10.1.63 network, your /24 that you've got, and then we're going to NAT that to the 1065.263 or whatever the case may be. So we're able to NAT that and say, okay, any traffic that comes off the 10.1 network will get translated to the 1063 network, and then gets shipped out. So all the router has to do on the private side is have a static IP and route that out to us. That's all that's happening. So what you're going to end up doing, well, this is the basic setup to it, but the very first thing you're going to see is setting up your iOS DHCP server. Now you can run DHCP, you can run DNS from the iOS on the router. I don't recommend doing that. That is more processor work for the router. I mean, if you're running a really small network, 30, 40 users, you have a decent sized router, no big deal. But if you've got hundreds of users, maybe thousands of users, and you've got a few different pools, not something you want your router having to deal with. You might throw DHCP on a local server. So that's what I would do. But what you're going to do is you're going to put an IP DHCP exclude address. This is where your servers would come in, or your interface IP addresses for your routers. You would put those in, and then you would assign your IP addresses accordingly. So it wouldn't assign 10.1 through 10.10 or 11.1 through 11.10. These would not get assigned to anything other than what is specifically assigned. So these 10 addresses would never get assigned to anything other than what's already configured. So that gives you range of, you can add or take away servers and stuff like that. So as you can see, coming down here a little bit, you're gonna DHCP. You're gonna go into set up your pool for router 1's fast 0 interface. You're gonna go in there. You're gonna say you're going to give DHCP available to that range 192.168.10.0 and a class C range. What you're going to do is you're going to say DNS server, and you're going to point out the DNS server IP address, and the default router will be 192.168.10.1, which will be R2's, right? R2 10.1. 10.1 is going to be R1's fast 0. So that'll be this guy right here. So R1 will be the default router for both the 11 network and the 10 network. I had to look at that real quick because I wasn't sure off the top of my head. But that's the default router that you're going to put in on R2 fast Ethernet 1, because what will end up happening is, and actually I'll get to this in a second, but you're going to configure the pools on router 2, so that router 2 will be the DHCP server. So same thing with router 2's fast 1 for the 11 network. Now if you come down just a little bit further, you have this thing called a helper address. Now what a helper address does is it takes the excuse me, it takes the incoming let me come up here. It takes the incoming broadcast from PC1 on the 10 network to R1's fast 0 interface, and it's a broadcast because he doesn't know where, because when he broadcasts out, he broadcasts with a 0 IP address, 0.0.0.0, and the MAC address is the MAC address of his interface card. So he sends a discover out there and says, hey, I need an IP address. And what R1's fast 0 interface gets, because that's the only other thing it's going to receive, because switch 1 just excuse me, switch 1 just forwards that broadcast, because it's a broadcast domain, onto R1's fast 0 interface. What R1's fast 0 interface does, when R1 receives that, it says, oh, you need DHCP. Well, R1's not running DHCP, R2 is. So what R1 does is it says, okay, well, I don't have that feature available on my router, so what I'm going to do is I'm going to forward that broadcast DHCP request and turn that into a unicast point-to-point connection to R2, which is what the helper address does. And your helper address will be the address of R2's serial 0 interface. So what you do is, when PC1 sends the broadcast of fast 0 on the router R1, R1 takes that and forwards it as a unicast. So it goes broadcast to unicast, and then unicast to R2, and it says, I need an IP address. This is the MAC address that I need. It gives it up, it does a discover. R2 goes, okay, well here you go, here's the IP address. Sends it back this way, so it goes back unicast to R1, and then it goes broadcast back down to PC1. Well, technically, it's still a unicast at that point, because the discover is the only broadcast. At that point, it's unicast back and forth at that point. So what ends up happening, PC1 goes, okay, yeah, I'll take that. That IP address is good with me, 10.65 or whatever the case may be. And so it sends a request back to R2. And it says, yeah, I'll take that one. That's what I would like to have for whatever my lease time is. And R2 goes, okay, cool. I acknowledge that you have that IP address. I'll take it out of the DHCP pool and take it out so that it's, it's in a binding now, what they call reserve. So it's binded now to your IP address. Your MAC address is binded to this IP address. So now it knows what to do for whatever the least time may be, 2 days, 3 weeks, whatever the case is. And then it sends the acknowledgement back to PC1. PC1 gets that and says, awesome. End of transmission between on DHCP. Now it has an IP address. Now it is free to roam the internet. That is the concept behind the helper address. The helper address takes, let me take one step back. In order for DHCP to work, you have to have a DHCP server on the local subnet. Well, if you don't have the luxury of having a DHCP server on every subnet, you need to compensate accordingly. So the helper address is what fills that gap. So you take your DHCP traffic on R1 and you send it to somewhere where you know it'll get. Or you could do it to like a Linux server. You can do it to a Windows server. You could do it to a Unix server. I think runs DHCP. So what you could do at that point, R1 sends it to wherever it's got to go, and you just on the helper address, which I believe is right a little farther down, is right here. So you're pointing it out to what do you call it? 10.1.1.2. Oh, because it's got two fast. It threw me off because I was like, well, that's not router 2's IP address, but because it's R1, because right here it says R1 on both its interfaces. So you would say they're both going to go to the same place. So it takes inbound DHCP requests from fast 0 and fast 1 and sends them to R2 to do DHCP. Now there's got to be separate pools for each one. Then it sends it back to the accordingly based on MAC address. So it's got well, I don't want to say based on MAC address, but the switch knows who's talking to who. So I'm a little sketchy as to when it comes back in here how it actually would go through. But if you do a debug, I think DHCP is an option, so you should be able to see the running config or the debugs working that way. So what'll end up happening is that's what'll happen. And if you do a show IP DHCP binding, remember I mentioned the term binding a second ago. It'll take these. Okay, it does do the MAC address, but and then you could assign at least addresses and so on and so forth. So 10.10 through whatever the case may be. And then, okay, so it does go through the, it doesn't show discover. Nah, it's not showing it the way I want it to. Because usually you would see, discover, it's not showing it. But anywho, and then you got your static routes and you configure OSPF. Now, configuring NAT. NAT's one of those technologies that or a service I should say, that if you don't get it, it's going to hurt you. Because NAT is going to be something that's used regularly. It overcame the IP address shortage in IPv4. There's still going to be NAT in IPv6 because you're going to have site local addresses or unique local addresses, meaning it only works on the inside of a enterprise or a company's network. Then you have your global IP addresses, and you're going to be able to NAT between them. So IPv6 should never, theoretically, ever run out of addresses. You should be able to assign an address to, and I'm not being facetious about this, every person in the world currently, whatever the number is, 7 billion and change or whatever the case may be, every person should get like, what was it, the last time I saw a statistic was like 3.5 million addresses. So it's some stupidly large range of addresses you can throw out there. But in order for NAT to work, there's actually 3 different types. There's static NAT, there's NAT overload, and then there's dynamic NAT. And there's 3 different ways of implementing NAT, and those are the 3 different types. So you're going to implement it based on the type that you want it to run with. So in this case, static NAT is taking a static IP address and mapping it to a static internal address, okay, to a static external address. Control Z. What does that mean? Well, let's say for instance you have a web server out on the internet, Okay, let me go jump back up here. You have a web server right here on the internet. This is your DMZ, just for the sake of argument. You have inbound traffic coming this way, okay, to this ISP, comes in on the ISP to this web address, okay, the 209.165.200.224. It comes inbound on this guy as a request for web services. Forwards the information to here. It's a static NAT translation, so he knows that if any traffic coming in on this IP address, this public IP address, it's going to get mapped statically internally to this IP address right here, the 192.168.20.254. So at this point, there will be a connection opened from the outside to the inside. So the 0001 to the fast00 to this web server. And this is what that is. And then the web server will respond with the web page out to whoever it is, and that's where a TCP connection opens up, and there's a connection open to it. And as long as the connection's open, the end user will be able to see the web, the web page. Now I'm gonna shoot down here just a bit, and now that's static NAT. Now you do have to have your addresses, your IP address, or I'm sorry, your interfaces labeled inside, outside, and so on and so forth. Now, dynamic NAT. What is dynamic NAT? Dynamic NAT is taking a pool of external public IP addresses, or well, we're going to stay with that one for right now. I don't want to get too complicated and confuse people. But you're going to take a range. So you're going to go 209.165.200.241 through, and you don't put just a space. That's all you put is a space. 209.165.200.246. So that's going to be your range of public IP addresses. That's what you want to advertise out to the world, and you're going to say net mask, and it's going to be a /8. So you're going to give them the ability, or no, so I'm sorry. Yeah, /8. Or /28, 29, /29. /29, which gives you 8 addresses. So there's 6 addresses possible with that range, because you have your base and your broadcast. So you're going to assign these public IP addresses to your router so that any traffic that comes in on those will be able to NAT accordingly. Now, if you come down just a little farther, you're going to have to tell them what you're going to NAT it to. So you're going to have, in order for these addresses right here, the 10 network and the 11 network, to get off your networks or off the local network and out to the internet, it's going to NAT it and say, I want to NAT 192.168.10. Whatever the IP address range is to, and I'm going to leave, and it's going to appear that I'm coming from this IP address right here as I'm leaving. And then any traffic that comes back to me is going to come in on this IP address right here, and it's going to come in to the 10 network, or whatever the case may be. Now, because there's a range right here, and there's a range right here, that doesn't necessarily mean that this IP address is the only one that's going to get used. It's whatever IP address is used at the time, because you've got a range, you have a range, the router will pick and choose accordingly. So, I don't know if they, so like I said just a second ago, when you NAT, and you do a 192.168.10.11, is going to appear to the outside world as 209.165.200.241. Okay? That's basically how NAT works. So, now you have NAT overload. In order to use NAT overload, you're going to tell that, because if I could scroll up just real quick here, it says IP access extended NAT. You're going to permit the IP protocol. Okay, that's IP, TCP, UDP, and ICMP. So you're going to allow TCP traffic, so web traffic, UDP like DNS and voice and video traffic, and you're going to allow this source IP address using this subnet mask out any destination. Is that what that means? So once you have the source and destination put in here, and you're going to allow it out anything that it wants to go see. Okay, so then you have NAT extended. This is a named access list, hence the term NACL, or named access control list. You're going to come down here, and then right here, this is I want a NAT. From the inside of my network, I'm going to source it to an access list named NAT on the interface 0001, and I want to overload that network. Okay, so what does that mean? Well, that means you're going to go based on port. And it doesn't show, okay, it does port 6. So ICMP port 6, I'm assuming that's a ping. But, yeah, extended ping. What that means is you're going to allow traffic. Excuse me, I've got the coughs tonight. Let me click back on here. You're gonna. Okay, they must have been playing around with something there, but you're going to say IP NAT. I would like to NAT from the inside of my network from a source access list. So you've already configured, and that's this guy right here. Alright, so this is your source access list. You created an access list of NAT pool addresses in order for this to work. So you're going to allow the 10.0 network the entire range, the entire Class C range, and the 11.0 network the entire range. You're going to allow them out 241 through 246, which is this range right. Where'd it go? I lost it. Where'd it go? Right here. Right there. So you want this range of IP addresses to be able to NAT to these. Okay. So anytime 192.168.10 network wants to get out any port, is going to use one of these IP addresses to get out. So any traffic coming back in to this network on one of these IP addresses will be NATed to one of these ranges. Does that make sense? I hope it does, because it took me a long time to understand dynamic NAT. And this is dynamic NAT at its heart. Now, I'm not going to get into merging networks together. That's just going to throw people off. But where was I at here? So going back here, you're going to say IP NAT. You want to NAT the IP protocol from the inside of your network to the source list. So you, like I said, you configured an access list. Actually, what I'm saying, it's saying what is the source, and you're going to say it's an access list. That is the source. What are the source IP ranges that I'm going to do that to? And this is a list, an access list, named NAT. You named your access list when you were configuring it, and it's going to leave its network once it's done traversing its own internal network. Once it gets to the outbound interface to the internet, this is the interface it's going to leave on, and then you're going to overload that. Meaning, let's say for instance you only had one IP address. Okay, let's say we had the .241 IP was your external IP, and you only had one public IP address to work with, and you had 1,000 users. Well, you're still going to overload it, but it's going to leave, and it's going to appear as it's leaving out the 241 colon, anything above 1024. Now, there is some technicalities to that when it comes to, like, if you're doing a source static, which I believe is right up here, right here. You can, now this is kind of plain right here, okay? But where you can get kind of technical, you can say IP NAT from the inside source. It would be a static IP address. So you're NATing 192.168.20.254, the private IP address, to the public IP address of 200.254. Now, you can map it based on what servers you have internally. You might have web servers, you might have email servers, FTP, you might have DNS, whatever servers you might have running. You can map it based on port. So you can go 192.168.20.254 space 80 for HTTP traffic, 25 for SMTP for email, for Outlook, or whatever you want to run, 21 and 20 for FTP. You could also do, like, say, 993 for secure email. I mean, that's a little outside of the scope of the CCNA, but you could do that. And you could say port 80 here and port 80 here. So it's going to be an HTTP point to static NAT translation from this guy to this guy. Now you would actually put, after the 254 you put a space, 80, space, 209, 165, 200, 254, space, 80. That's what you would do. That's how you would configure that. Well, this is actually applying it, but when you're configuring it, you would put that information in. So, but that's the basic concept to it. I mean, it's not really that difficult to figure out, but I would definitely recommend, if you haven't gone to see INE's website to check out their free CCNA bootcamp, definitely go check their YouTube video or YouTube channel out. And actually, what I did is I just threw all the script into the routers to get them all running, which my network is completely up and running. So that's the concept. And it's not really difficult. I mean, it can be at first if you've never heard this concept before, DHCP relay, which is actually what and the relay is actually a really good term, because if you ever watched a relay race where, you got the guys going in a circle or on the track, and you may have a 4x100 where you have 4 people running 100 meters, equaling a quarter of a mile. So you'd have the relay. It comes in here on FAS0/0. It hits the relay agent, and the relay sends it off to here. And then he relays that information back to him, and he relays it back to him. So you're just relaying information from one place to another in order to get DHCP to work. That's what the relay kind of means. But that's the basic concept to it. I mean, it's really not that difficult. If you see on an interface, let me bring this guy over here, and actually I was making sure configurations were working correctly. And show run, it says helper address. That's what you want to be paying attention to. So helper address, that means it's going to send DHCP requests from R1 to R0 in this case, and then R0 is going to send those responses back to whatever interface or whatever internal what's the word I'm looking for? The internal user or internal computer that requested them. That's the basic concept to it. So, I don't know exactly what else I can cover when it comes to NAT and to stuff like that. I do know that when you guys get to access lists, that's going to be a little complicated, because access lists do VLANs, they do NAT, they do DHCP, they can do DNS. You can block what ranges can get to what ranges are blocked from this or blocked from that. So if you don't understand access control, that's going to be one of your big things you're going to want to know before you go take the exam. Because I know they're heavy on that, because it's one thing to be able to get full IP reachability. It's another thing to be able to secure your network so that some rogue user doesn't just get on your network and start wreaking havoc. So that's the concept. If you have any questions, rriker82@yahoo.com. Shoot me an email. rriker82@gmail.com. Shoot me an email. I welcome responses. Leave a comment if you think I'm full of crap, or maybe I filled in a gap for you. If you'd like a little more detail, maybe drawn out type of situation where I go on a whiteboard and I explain things in more, a little more granular detail. Maybe I'm on the command line and I give you a couple other explanations or examples. I can do that as well. I'm in the same boat as you guys. I'm going for the CCNA as well as you are, and knowing the concepts is going to be your biggest challenge. Understanding it, and not only understanding it, being able to configure and implement it. And then once you've got that down, being able to troubleshoot it or figure out why it's not working. And if you configured it wrong, which is very easy to do, especially when you're dealing with extended access lists, and you're going based on, you're trying to block a certain protocol from a certain IP address on a certain port, you can get granular at that level. So, but that's pretty much all there is to DHCP relay and how NAT works. Like I said, any questions, shoot me an email. So I hope this has been informative for you, and I'd like to thank you for viewing.